Our last example is a review on how to do average rate of change. Average rate of change can be done on any type of curve. Doesn't have to be just quadratic equations like we've done in the past. The Ares 5 rocket was designed to carry as much as 75 tons of supplies and 4 astronauts to the moon and possibly even to Mars. The table shows the expected g-force of the rocket over the course of its 200-second launch. So you can see in the table there, we have the first column represents the time in seconds. That's what the S stands for, time in seconds. And the second column is the acceleration in G's, which is the abbreviation for g-force, which is how much gravity pulls upon you. By definition, a g-force is the acceleration due to gravity. Part A is to find the average rate of change. Recall from the last unit that rate of change is the same as slope, but dealing with rate of change, we oftentimes will allow decimal answers. Those are considered to be okay, whereas if it was slope, I would prefer that you would leave it as a fraction. Also, it doesn't specify which times we are going to find the average rate of change over. In cases like that, if we're just finding the average rate of change over the entire, in this case, launch, we're going to use the first ordered pair. I'll spit it out here in a second, and the last ordered pair. So we are going to be finding the slope between those two values first. So using the slope formula, which is y2 minus y1 over x2 minus x1, we will do, let's call this our second point, and we'll call this one our first point. That's going to be y2, which is 2.2, minus y1, which is 1.34, over x2, which is 200, minus x1, which is just 0. So 2.2 minus 1.34 is 0.86. Over 200 minus 0 is just 200. And when you take 0.86 divided by 200, you get 0.0043. So that is the average rate of change. But part B has you interpreting the results. To interpret the results of an average rate of change, we're going to label the units as y units per x units. We're going to change it to y units per x units. So it's going to be our y units is our acceleration in g's, and our x units is time in seconds. So I'm going to say that our label is going to be 0.0043 g's per second.